Hello. Yes, ma'am. I'm audible.
Yes, sir.
Okay.
Sad.
Okay, fine. Yeah, ma'am. So, like after the class, no, like I will upload the recording. Okay. And
Okay,
then
okay,
you
sir.
can
No
share it.
problem.
Mm. Oh yes, ma'am. Let's bear 2 to 3 minutes, and then we can continue. Okay.
Okay, sir. No problem. I will.
Yes, Ravi Teja. Where is Jaya?
Yeah, she has just reached home. She's joining, sir. 1 minute.
Okay.
You can start the class, sir. She will be joining.
Okay. Fine. Yeah. Fine, guys. So let's just start. Let me share my screen, and then we can start. Fine, guys. So can you please confirm? Is my screen visible?
Yes, sir. It's visible.
Okay. Fine. So fine. Today we are going to start the new topic that is called encoder decoder. Okay. And this is the very important topic for the NLP and generative AI because whatever the model that we have in a NLP, like advanced model, I can say, like bot, if I talk about some advanced model in NLP, like bot or GPT or Robota, or here like in a LLM, if I talk about the LLM model, then Llama, okay, Palm. So these are the complete, whatever the new architecture that we have in the market for LLM, generative AI, or the complete, I can say the NLP SOTA model, the base architecture that we have that is called encoder decoder, and the second one that is called transformer. All the architecture, all the LLM, generative AI, and the SOTA model, SOTA NLP model, all the architecture, the base that we have that is called transformer. So this is the base model that we have the transformer. But first, let's try to understand the encoder decoder, because if we are able to understand the encoder decoder easily, that we can understand the transformer. Okay. So we have learned some topic that is called RNN and LSTM. We are aware about these two topics. Okay. So what happened in RNN? RNN mostly work on the sequence to sequence data. Sequence to sequence data, it means like whenever we are going to work on the text generation application. So one of the application that we have that is called text generation. Okay. So whenever we are working on these types of the application that we use RNN, we use LSTM. Okay. But we have some advantage, we have some disadvantage for this particular RNN and LSTM. So if I talk about the RNN, so in a RNN that we have the one disadvantage that is called vanishing gradient. Okay, vanishing gradient. So this is the issue that we have in a RNN. Second issue that we have that is called slow processing. Slow processing. So this is the first model that we have in a NLP. Okay, so that's why whenever we have the long data, like if I talk about the long data, it means let's say the 1 millions or the 2 millions of the record that we have. In this case, this particular RNN model, it takes a lot of time to do the processing. Apart from this one, let's say like in this particular 1 millions of the record that we have the long sentences where we have the multiple sentences that we have in one sentence. Okay, so let's say that we have the here full stop, comma, full stop, so on. So let's consider this is the long sentences that we have. Now, whenever we are going to pass these types of the data to the RNN model, so after some time, this particular RNN model is not able to remember the entire information, whatever the information that we have in this particular sentence, in this particular complete sentence. So let's say if we are going to pass the data starting from here. So when we pass here to here, our RNN model, it is able to remember the data. Now, when we proceed with the second sentence, it's started forgetting some types of the data, some data from the first sentence. So this is the issue that we have in RNN. Same issue that we have in the LSTM as well. So whenever we pass the long data, so long short term memory. Okay, long short term memory. So long short term memory means it means after some time this particular model, LSTM model, it is able to forget, like it is not able to recall or the remember our entire sentences. Okay, so that's why we need some better model so that our model can understand each and everything, the entire sentences, doesn't matter the sentence is big or the sentence is small. So we need some model, or the architecture where our model can understand each and everything, the complete information, whatever the information that we are going to send. So here encoder decoder come into the picture. Okay, so somewhere in a blog that you will get the name that is called sec to sec. Somewhere name that you will get sec to sec or sequence to sequence. Okay, so these are the names that we have for the encoder decoder, sec to sec or the sequence to sequence. Okay, now what happened in a RNN? Okay, in a RNN, we send the data. Let's say this is the RNN architecture that I'm going to create. Okay, so what happened? Let's say that here we have the data that we are going to send. Okay, now after that, what happened here? We are going to pass some types of the data that is called x1. Okay, now this is the RNN model that we have. Okay, so let's say the RNN model. Now whatever the RNN like x1 data that we are going to pass to the model, this particular RNN model, let's generate some types of the output. X1 is the input data that we have, and here that we are getting the Y1 that is called our output data. Okay, now what happened? Let's say like here the sentence that we have, I love apple. Now whenever we are going to send I as a X input, so this is the X1, this is X2, this is X3. Now whenever we are going to type in our mobile phone, we are getting the multiple suggestion. Okay, so I am, I something, and the so on that we are getting the multiple suggestion, 2 to 3 suggestions that we are getting in our mobile phone. Right. Now same thing happens here as well. So let's say here we are going to pass I. Okay, so input equal to I data that we are going to pass. So definitely our RNN model generates some types of the output. So let's say this is called our output that we have, that is called Y1. Now what happened again? Let's say second time. Let's say second time that we are going to send some types of the input data. Some types of the input data we are going to send. So this is X2. Now X2 that we have, that is called love. And this is the input number 2. Input number 2 that we have. And again that we have the RNN model that we have internally. That now whatever the X2 data that we are going to pass here, Definitely this particular x2 data, it will generate sometimes with the output, sometimes with the output. Okay, so here let's say the y2 output that we are getting. Now what happened here, whatever the output that we have here, so along with the next input, just focus on the word guys. Okay, so here whatever the next input data that we are going to send, so along with our next input data, we can pass our previous output as an input to generate the next consecutive word for this particular sentence, that is called S1 I love apple. Now if you want, you can just try in your mobile phone as well. Okay, so if you want, you can just try out in your mobile phone. So let's say here that I'm going to open my mobile phone. Okay, so here I'm going to open my mobile phone and I'm just using my WhatsApp. Okay, you can try from your end as well. Okay, so whenever you are going to search something, let's say like here I'm going to search, first that I'm going to write I. Now after that, here I'm getting the three suggestions. As I mentioned, three suggestions that we are getting. First one is have, second is am, and the third one is will. Okay, so these three suggestions that we are getting. So let's say here that we are getting the three suggestions. Here in y1 output that we are getting the three suggestions, that is called have, am, and will. These three suggestions that we are getting. Okay, now what I'm going to do, now I'm going to continue with the next word. So what is the next word here? Next word that is called love. So here I'm going to write love. Now I'm getting three suggestions. Okay, now again that I'm getting the three suggestions, but before getting the next suggestion, now what happened here, we are writing the two words here, two words. First is a next word that is called love, and the second one is a previous word that is called I. But here what we can do, whatever the based upon this particular previous input data, whatever the output that we have generated, this particular output that we can send to the RNN model along with the next input data to generate our next output. Now again same thing that we can do. So next input data that we have, that is called here, that is called apple. So here we can send x2, we can send here x3, that is called apple. Again here we are passing the RNN. Now what we can do, this particular output that we can send here along with our next input data, that is called x2, and then it will generate some types of the output here. And this is called our final output that we are getting. This is called our final output. So what happened here? Every time we are sending the one data, we are getting some output, same output that we are sending as an input along with the next input data, that is called love and apple. So this is called the our previous output. This is called the previous output. So you can say like h1, h0, h2, h3, so on, that you can just name it. Okay, the previous output you can just name it h1, h2, h3, and the so on. Okay, now x1, x2, x3 that we have our input data, and based upon this one that we are getting down. Okay, so this is called the simple RNN architecture that we have. Now what happened in a encoder decoder? So let me generate the encoder decoder architecture. So till here guys, can you please confirm everyone clear? Till here everyone clear?
Yes, sir, clear.
Clear? So now if I create the final RNN architecture, so can we create like this one? So let me design it first. 1, 2, 3. Okay, and let's skip it here, the last one. Okay, now what we are doing here, so here the first thing that we have, let's say the everywhere that we are using some model that is called RNN model, RNN, and again that we have RNN here. So here we are getting some types of the output that we are sending. So let's say x1, we are getting some types of the output, right? So here let's consider h0 because this is the first output that we have. That's why I'm going to consider h0. Now what we can do, this particular output that we can send to the next RNN, this one. So I'm just connecting this one. Again that we are going to send the next data that is called x2. We are getting some types of the output that is called h1. Now what we are doing, this particular h1 that we are sending as an input, and we are sending our next input data, that is called x3. We are getting here some types of the output, that is called s2, and the so on, that we are going to connect with the last layer, that is called hn, because here we have just taken the one sentence where we have the 3 words. But in a real time scenario, it might be possible that you will get the 100 word, 200 words. So that's why we are going to consider. So here we have the xn, it means the multiple data, and here that we have the h of t, that is called the multiple previous output that we can get as a input to the next layer. Okay, so in this way, this is the complete RNN architecture that we have. Calculation batch, we all know how that we calculate. Okay, so here what we can do, so here we can say f of h of t minus 1. Minus 1, why minus 1? Because this is the previous output that we have. But as we are sending the first time, so the previous output is equal to 0, previous output equal to 0, comma, x1. This is called our first input data. Okay, so if I conclude in this way, so f of 0, comma, x1, f of 0, comma, I. Now second time, this particular previous input plus next word, that is called love. Again, I love plus next word, that is called apple. Okay, so in this way that we are sending a data to our neural network, and then it generates out, okay, in a RNN. Okay, so this is the complete RNN architecture that we have. Now let's try to understand a complete encoder decoder. Okay, complete encoder decoder. So here I'm going to create the complete architecture for the for a encoder decoder. Okay, so the first thing that we have here, this is the first part that we have, and here that I'm going to create the second part. This is the second part that we have. Okay, so this is the complete architecture that we have, the RNN and the I can say the encoder decoder architecture. Okay, so this is the complete encoder decoder architecture that we have. Now what happened in this particular two encoder decoder architecture? Let's try to understand those things. Okay, those things. Now in a encoder decoder, we have some base architecture. Okay, we have some base neural network. Again, a neural network is anything. Okay, so let's say that we are developing some types of the application. We are developing some types of the application, like let's say that we are developing the text summarization. Text summarization, or we are developing a text generation application. Text generation, or we are developing the machine translation. You can say the machine translation, or you can say the language translation from one language to another language. Okay, so whatever the application that we are developing here, the base architecture that we can use here is a RNN, or we can use the LSTM, or we can use the GRU. Again, depends upon the requirement. These are the different base architecture that we have. Okay, so here you can see that I've created the two things. This is called the encoder. This is called the encoder layer. Encoder layer. And this is called the decoder layer. Okay, let's try to understand encoder decoder theoretically first of all, then we can do the complete calculation and all. Okay, so encoder, it means this particular layer, encoder layer, it accepts the input data. It accepts the input data, and based upon these models like RNN, LSTM, or GRU, it will do the complete pre-processing for our data, and then it will generate the final output using the decoder layer. So the encoder layer, it will help us to encode the input data. Decoder layer, it will help us to generate the final output based upon the encoder data, whatever the encoder data that we have taken from the users. Okay, so encoder layer, it will help us to take the input, do the processing, and then it will forward to the decoder, and then decoder layer, it will help us to generate the output. But how these things work, how this complete encoder decoder architecture works, Let's try to understand those things here. Okay, so here let's say that I'm going to create the multiple multiple base model. Okay, so let's say here I'm going to create the multiple base model like only RNN. Let's keep it only RNN. Later part that we can change. Okay, so let's say this is the first RNN that we are going to create. Okay, first RNN. Again here we are going to create the second one. We are going to create here the third one. Okay, so total 3 model that we are going to define here. Again here let me define the decoder base architecture as well. So 1 and 2. Again we can define multiple as well for the explanation purpose that I'm going to call only one. Okay, so these are the base architecture that we have. Let's point out this one. These are the, you can say, base architecture. Okay, now the base architecture is anything RNN or LSTM or GRM. Okay, so we can use anything like RNN, LSTM or the GRE. From here we can use anyone. Okay, now let's say for the simplicity, let's keep only one model that is called RNN. Okay, so here that we are going to call RNN. Okay, RNN. Again here that in a decoder that I'm going to call one model that is called RNN and RNN. See guys, why I'm explaining this particular architecture, because let's say if you are going to attend any like NLP or the generative AI interview, and if the interviewer they ask anything related to encoder, decoder or the transformer, that you need to explain this particular architecture. Okay, and apart from this one, as I mentioned, these are the like encoder, decoder and the transformer is a base architecture that we have for our all the NLP, generative AI and the LLM that is called large language models. Okay, so these are the base architecture that we have, encoder, decoder and the transformer. So try to understand everything in a detail. Okay, now in an encoder again that we are calling 3 base model that is called RNN every pair, and again in a decoder 2 model that I'm going to define. Now what happened here, let's keep it the one example. Okay, so let's keep the same example that is called I love apple. Okay, so this is the complete sentences that we have, where we have the total 3 words. Okay, total 3 words that we have. Now what happened here, let's say here we are going to pass some data. Let's say that we are going to pass some data that is called x1. Okay, x1 data that we are going to pass. Now whatever the data that we are going to pass here, again that we have some previous layer here, previous layer. Okay, that we can say the previous output, but right now as the first time that we are going to send the input data, so what we can say, this particular previous h of t. Okay, so the previous output that we can denote as a h of t. So h of t is a, I can say 0 right now. Okay, so h of t is 0 as we are going to send our data first time. Okay, now what happened in RNN, whenever we are sending a data that we are getting the output. Okay, but here in a encoder decoder little bit different architecture that we have. So what happened here in a encoder decoder, whatever the input data that we are going to pass, and whatever the model, this particular RNN model understand based upon this particular input data, and whatever the output about this particular RNN model generate, it directly send to the next model, next architecture, next base architecture. It can't generate the output here. No, it send the complete processing to the next RNN model. Now again here we are going to send the next input data that is called x2. Again this particular model understand this particular x2 data, and then again it will send to the next model that is called RNN3. Again here we are going to send the next data that is called x3. So here that we started from the h0. Now here I'm going to assign the name that is called this one is a h2. This one is a it's a h1. Okay, this one is a h2. Now whatever the output that we are getting here, this particular output, so this particular output that we can say this is a context vector. This is called a complete context vector here. So what happened here? Whatever the input data that we are going to send, okay, the input data that is called first data that we have here, x1, x2, x3. Okay, so what happened in a encoder? In a encoder stack the multiple RNN together, multiple model together. We can say the encoder stacked multiple models together to take the input data in a sequences, so here I'm going to highlight. Okay, so encoder stacked multiple models. Now models is anything like RNN or LSTM or GRU. Okay, right now that we are using here the RNN only. Okay, so again, it's totally up to us that we can change these particular things. Okay, so what we are doing here, so encoder stack multiple models that is called RNN, LSTM, GRU together to take the input data sequentially. Okay, so this is called our input data, where like our encoder stacked a multiple models together, okay, to take the input data sequentially, and then this particular sequential data one by one it will send to the our models, whatever the base model that we are using, that is called RNN or LSTM or the GRE. Okay, so this is the first point that we have. Now in every timestamp, in every input, in each input as every timestamp, the hidden state that is called H, hidden state that is called H is updated according to the input data. Okay, so here that we are sending the x1. Okay, so based upon this one that we are getting the hidden state that is called 0. Okay, now here again that we are sending the next data, so here we have the different hidden state. Again we are sending the next data that is called x3. Here we have the different hidden state. Okay, so in every timestamp the hidden state of H is updated according to the input data at timestamp based upon this particular data, based upon our input at timestamp t. We can say timestamp t whenever we are sending the our input data. Now after that, so after all the inputs, okay, whatever the input data that we have, so after all the inputs are read by the encoder model, the final hidden state that is called this one, the final hidden state of the model represents a context vector, or I can say the summary of the whole input sequences. This is called the context vector or the summary of the whole sequences. Okay, now whatever the context vector that we are getting here, this particular context vector that we can send to the decoder, this particular context vector that we can send to the decoder here, decoder. Now what happened in a decoder, whatever the context vector that we are sending, so this particular decoder model, it will take the our all the context vector one by one, and then it generate the output. Okay, so here this particular RNN generate the first output that is called y1. Again this particular y1 it will send to the next base architecture. Okay, so y1, then it generate the next output that is called y2. Let's say this is the final one, this is the final output that we have. Okay, so in this way the complete architecture, complete encoder decoder architecture works, where whatever the data that we have, that we send to the encoder layer, and the encoder layer take our entire data as an input in a sequences, and then it convert into the context vector, and then whatever the context vector that we are getting, our encoder sending to the decoder to generate the final output. Okay, so this is our complete encoder decoder architecture that we have. Now let's consider one more input sequences, one more example that is called let's say I am a student. Okay, I am a student. So again that I'm going to say like take the simple input data. Okay, so what we can do first of all, whatever the data that we have input sequences, I'm the student. Okay, first that we can encode this particular data, encode this particular complete data. Let's say I am a student. Okay, I am a student. So first what we can do, encode. Okay, we can do the encoding. Now how many tokens data that we have, how many words that we have total. So total 4 words that we have, 4 words. It means that we can say the 4 tokens, total 4 tokens that we have. It means 4 times that we can send this particular data to the encoder layer, at each timestamp. At each timestamp, it means like on the different timestamp that we can send our all the 4 words. And then the hidden state that is called H, this one at every timestamp, this particular H will be updating using the previous hidden state and the current input data, whatever the current input data that we are going to send to our encoder layer, and then in a last, whatever the updation hidden layer that we have, we will get the context vector, and this particular context vector that we can send to the decoder, and then the decoder generate the output sequences by predicting the next output that is called y of t. Okay, this particular output based upon our context vector, whatever the context vector that we have. Okay, so yes guys, just confirm once the encoder decoder architecture is clear. If no, just confirm, I will explain you again. Okay, because this is the very important to understand the next architecture, because now whatever the architecture that we have going forward, those all the architectures are the connected one. So just confirm if you have any doubt, anyone.
No, sir, clear, sir.
Yes, Ravi Teja,
Yes, sir. Clear.
clear? Fine.
Yes, sir.
Now, apart from this one, okay, so what we are doing, we are just taking the data, we are sending to the encoder layer. Now, in an encoder that we have some base architecture that is called RNN, LSTM, or GRU. Then at each timestamp that we are sending a data to the encoder, and based upon the hidden state, it's update the weight every time, and then it generates the final context vector, and then context vector that we are sending to the decoder to generate our final output. Okay, now in between again that we have the many things. It means whatever the input data that we are sending, that we need to do the encoding for this particular data, right? Apart from the encoding, that we need to apply some like neural network functions like optimization that we need to apply. We need to do the back propagation. We need to apply the like softmax function. Okay, we need to use the loss rates to calculate the loss. So these are the things that we do in between. Okay, but this is the base architecture that we are. Where in encoder it takes the input data, decoder generates the final output based upon our encoder, whatever the as a encoder, whatever the data that we have taken. Okay, now what I can do, let me show you one architecture here. Okay, so if I jump here, so encoder decoder architecture, let me show you the general architecture here, or let me find out some images on the Google if I will get something. Yes, so here you can see that we have the very simple data, like very simple architecture that we have. If I open this particular architecture in the next page, so let me open it. Now as you can see in this particular architecture, okay, so whatever the points that we have discussed in now, the same point that we have here, right? So let me open my pen once, epic pen. Okay, fine. Now as you can see, like here we have a different data. Okay, so let's say here we have the x1 data. We have the x1 data, we have the x2 data, we have the x3 data. So let's say this part, sorry, this part that we have is a encoder one, and this is the decoder one, where we are generating the output based upon the context vector, encoded vector, or we can say the context vector, whatever the context vector that we are getting. Okay, those particular context vector that we are sending it to the decoder so that we can generate the out. Okay, but at the end, as you can see in this particular encoder, what we are doing, whatever the input data that we have, like x1, x2, x3, that we are sending to the encoder layer where we have the base architecture that is called RNN. Now, the base architecture is anything, LSTM, RNN, or the GRE, anything that we will get based upon our use cases. Yes. So whatever the application that we are generating, like let's say text summarization or text generation or a machine translation. So based upon our application that we can select a different types of the model here, okay, like RNN, LSTM, and GRU, okay. But the at the end, what we are doing in an encoder, we are taking an input data, okay, we are taking an input data at every time based upon the hidden layer that we are doing the calculation, and then we are getting the context vector, and those particular context vector that we are sending to the decoder, and then our decoder, it helps us to generate the output final output. Okay, so this is the complete architecture that we have. Now let me show you the architecture with some different like base name. Even like this is the one of the architecture that we have for the RNN, sorry, for the like LS like encoder decoder. Now here as you can see that we have the some little bit complex model, complex architecture. Let me show you something else. Yes. Now see, this is the one of the architecture that we have again for the encoder decoder. Okay. So here you can see that we have the encoder part. So left hand is a encoder part. So whatever the input data that we have, like I love Apple, what we are doing, first of all, that we are doing the encoding. Those particular encoding that we are sending to the our encoder model. Now, again, in a encoder, as I mentioned, that we can use anything like RNN, or we can use the LSTM, or we can use the GRU. Now, as you can see that the researchers, they are using here the by LSTM model. By LSTM model. Okay, so first right hand side, and then left hand side. So this is called the by LSTM model. I hope like you are aware about these things. If no, check it out the LSTM recording session. Okay, so this is the by LSTM architecture that we have. Now at the end, whatever the context vector that we are getting, this particular context vector that we are sending to the decoder, and then in a decoder here they have the softmax activation function, and based upon this one, this particular decoder, it helps us to generate the output. Now let's say that we are working on some application like machine translation. So we have the input data, let's say input data that we have in English, and that we need to like convert into the Telugu. Okay, so here we have the target sequences as well. So what we need to do? We need to convert those particular target sequences into the encoding. Okay, it means the numbers, and then we can generate the output. Okay, so again here you can see like the researchers and the member, like the different members, they are using the different base architecture that is called by LSTM. Okay, so it's totally up to us whatever the application that we are developing based upon our application requirement, that we can use the different models, different base architecture. Okay, so this is the different architecture that we have for the encoder decoder. Okay, so yes guys, just confirm what till here if you have any doubt. Anyone?
No, sir, no doubts.
No, sir.
Okay, fine. Now what I can do, let me remove this one first. Yes. Let me go back. Let me show you something. Apart from these two, do we have anything else? Again, here, like the researchers, they are doing the same thing. Okay. So this is the little complex architecture that we have. So as you can see here, that we have the encoder. This is the complete encoder part that we have. This is the decoder part that we have. We have the input data. Okay. So we are just converting the input data into the numbers. Then we are sending to the by LSTM. So again, this is the forward. This is the backward part that we have. It means this is the by LSTM model the researchers they are using. Okay. So here that we have the backward propagation, forward propagation. Okay. Attention. Then whatever the context that we are getting, this particular context that we are sending to the here we are sending to the decoder, and then this particular decoder part, it will help us to generate the final output. Okay, so this is a little I can say the complex architecture that we have, but the base is the same thing where we are just taking the input data, we are doing the processing at every time stamp, and based upon this particular time stamp that we are generating some types of the output with the help of decoder. Okay, so here you will get the different types of the multiple blocks that you will get, okay, on the Google. Okay, so as you can see here that we have the same thing. Okay, so the encoder decoder. Now here we have converted the data input data into the encoding. This particular encoding that we can send to the encoder to generate the final output. Okay, now in a RNN, as we have learned in a RNN and in a LSTM, that we have some advantage and we have some types of the disadvantage. Okay, in RNN, we have some types of the advantage and we have some types of the disadvantage. Same thing that we have in a encoder decoder as well. Okay, same thing that we have in a encoder decoder as well here. Okay, so if I talk about the advantage and disadvantage, so here I'm going to segregate the advantage. Here we have the disadvantage. Okay, so the first advantage that we have in a encoder decoder, that is called flexible input output length. Flexible input and output length. It means encoder decoder models can handle the variable length input and output. Variable length, it means like let's say like we are working on the text summarization data. So let's say we have one page example. Okay, so let's say that we have the one page PDF file. Now if we do the summarization, okay, so let's say in a one page that we have, let's say a total 500 words that we have. Now let's say if we do the summarization for this one, so we will get the summarization in 100 word or 50 word or 70 word. Okay, so this is called the flexible input output length, where we have the variable length of input and output. Variable length, no fixed, variable for input and variable for output. Okay, so this is the first advantage that we have. Same thing that we do like whenever we are developing the machine translation application. So if I show you one example here, so let me open my translator, and here I'm going to write like I love Apple. Okay, now you can see English word that we have, that is called 3. Output that we are getting total 5. मुझे सेब बहुत पसंद है. Now say show on if I convert into the different language. So as you can see, for the Spanish that we are getting the 4. Show on if I select something else that we are getting 3, and if I select something else that we are getting something different. Okay, so this is the variable input output. It means there is no fixed size for our input data and for our output data. So this is the first advantage that we have for the encoder decoder. Okay, now second advantage that we have, that is called contextual understanding. Contextual understanding, it means the encoder model capture the context of the entire input sequences, because we send the entire data to the encoder model, right? So that's why encoder capture the complete context of our entire input sequences, and then it allow the decoder to generate the output that consider the overall meaning overall meaning for the particular encoder data, or the particular incoming data, whatever the incoming data that we have from the encoding. Okay, so this is called the contextual understanding, where encoder capture the context of the entire inputs data, and then it's sent to the decoder, and then it allowed the decoder to generate the output that consider all the overall meaning for our input data. So this is the second advantage that we have. Now third one, that is called sequence to sequence task. I can say the effective for sec to sec task. That is called sequence to sequence task. Now, this particular model, encoder decoder, it is well suited for the task where the input sequence differ from the output sequence. That is called like translation from one language to the another language. Text summarization, because in text summarization that we have the 100 PDF. Now after doing the summarization that we will get 10, 15, 20. Okay, so here that we have the different variable length that we have for our the input and for our output data. Okay, so these are the some of the like advantage that we have. First one is a flexible input output, second is a contextual understanding, and third one is a effective for the sequence task, sequence and sequence task. Okay, now we have some disadvantage as well. Okay, we have some disadvantage as well. First disadvantage that we have, and this is the most important disadvantage that we have, that is called memory. Sorry, it's a memory limitation. Memory limitation. So the encoder decoder model, okay, in a encoder decoder model, what happened whenever we have the long sequences of the data, in this case that we are getting the memory fail issue whenever we are developing the application. Okay, so whenever we have the long sequences of the data, that we lose the detailed output, or I can say the detailed information from our input data. That's why we are getting the memory error whenever we are using the encoder decoder for the long sequences of the data. So this is the first disadvantage that we have. Second disadvantage that we have, that is called high computational cost. High computational cost. Okay, so encoder decoder, whenever we are using this particular model, it takes like lots of GPU, and whenever we are using a GPU, it means that we need to pay a lots of amount, right? So this is the second disadvantage that we have, that is called high computational cost. Okay, now third that we have the training issue, or I can say the training challenges, training complexity. It means when we train a model on the large data set, okay, so in a large data set that we are getting the, I can say the 95% of the accurate output. But whenever we are using the small amounts of the data, so in this case it might be possible, I can say like 30 to 40% of the time, that we are getting the inaccurate output. Okay, so this is the training complexity and the training challenges that we have. Whenever we have the less amounts of the data, that we are getting the less accuracy and incorrect output. Whenever we have the high amounts of the data, large data set, okay, in this case our model performs well, it will provide you the accurate output. Okay, so these are the some of the advantage and the disadvantage that we have for the particular model that is called encoder decoder. Okay, so yes guys, let me know if you have any doubt till here. Anyone?
No, sir.
Yes, in like encoder, like advantage, disadvantage, anyone?
No, sir.
All clear, right? Okay, fine. Now we have some application for the encoder decoder. Okay, we can develop a multiple application for the encoder decoder. So first application that we can develop, like, let's say here, let me write first, like application for encoder decoder. Let's write ed, encoder and decoder. Okay, so the first one that we have, that is called machine translation. Machine translation. Okay, where the encoder convert the sentences into the source language into the fixed length of the context vector. Okay, so encoder convert the sentence into the source language into the fixed length of the context vector. Then decoder use those particular vector to generate the sentences in a target language, like English to Hindi or English to Japanese or English to Spanish. Okay, now second that we have, that is called text summarization. Text summarization. Now here again, encoder process the entire full length of the input text and then creates the context vector. Then decoder generates the shorter, or I can say the summary of our complete context. Okay, so encoder convert the full length of the text data, then create the vector, and then decoder generate the final output. Now we can use this one for the image captioning as well. Image captioning. Okay, in a image captioning, first CNN, convolutional neural network, encoder extract the visual features from the images, and then with the help of decoder generate the textual description based upon the features, whatever the features that we have extracted for the CNN. So here that we can use the CNN in an encoder, and here we can use the RNN for the decoder. CNN that we can extract the features, RNN that we can generate the output. So here we are using the two different model for the encoder and for the decoder. Apart from this one, that we can use for the chatbot as well. Chatbot. Okay, now we can use for the speech recognition. Fifth, that we can use for the speech recognition. They can use for the question answering. They can use for the code summarization and code generation. Okay, so these types of the application that we can develop with the help of encoder decoder, because here, because first part, like the input part that we can do with the help of encoder, and the output part that we can do with the help of decoder. Okay, so these are the some of the like application that we can develop. Okay, now what you can do, guys, so just go to the Google, or what I can do, I will share one or two blog. Okay, one or two blog, just go through those particular blog. Okay, so that you will get the understanding, and based upon this one, that we can discuss the next research paper. Okay, because next topic that we can discuss the research paper, that is called attention all you need. Attention is all you need, and this is the very famous architecture that we have. And even during the interview, if you are able to explain this particular research paper only, or I can say this particular architecture, okay, then no one going to reject you. Easily you will get the offer letter. Okay, if you are able to explain this particular architecture. And definitely, if you are going to attend the interview for the NLP or for the generative AI or for the LLM, definitely you will get this question where you need to explain the transformer architecture or encoder decoder architecture, or I can say the attention is all you need research paper. Okay, so just go through this particular blog. I will share after the class in a group. Go through the blog so that in the next session, easily that we can understand this particular architecture. And this particular architecture, it will take minimum 4 to 5 hours, even more than that. Okay, because here in the first session, I will explain you this part only. And this part, it will take approx 1 to 2 hours. Then one session for this one session for this one, and one session for this one. So don't think like, okay, so this is the two architecture, two simple architecture that we have. No, this is the very big architecture that we have. Okay, everyone, clear till here?
Okay, sir.
Yes,
Yes,
sir.
Ravi Teja, Jaya.
Jaya is not an
Okay,
analyst,
okay,
so she doesn't have mic.
okay, fine, no issue, no issue. So I hope like till here everyone clear, right?
Yes, sir.
Okay.
Yes,
Yes.
sir.
Okay, fine. Fine, guys. So yeah, no issue. What you can do, like I'm just sharing this particular one blog, okay? And make sure, I hope you have noted down this particular like points, whatever the advantage, disadvantage that I have mentioned. If you need, I will send you the return, like the complete written doc file as well. Just go through the doc file so that we can understand the next research paper, because this is the very important research paper that we have for the LLM generative AI, because transformer is a base that we have for the entire LLM and the entire generative AI models. Okay, only we need to play with the parameters, nothing else. Okay, if I give you the one simple example, so let's say if you are able to understand like linear regression and the logistic regression. Okay, now as a mentor, if I say, okay, so what you need to do, you just need to change the parameter for the linear regression and the logistic regression and build the complex model. So same thing that we have in the generative AI and the LLM. Base that we have, that is called transformer, and based upon the transformer architecture, we have the entire other LLM models and the generative AI models. Okay, so please go through this particular file, go through the lecture once again, try to understand this one and the next architecture only. If you are able to understand two things, easily you can crack any interview, easily you can build any models from the scratch. Till now, we are using the different models, pre-trained models, as well as we are using the API. Next, going forward, after completion of the transformer, that we can build the models, we can fine tune from the scratch based upon our specific task. Okay, got it,
Oh,
everyone?
yes, sir.
Yes, sir.
Okay, fine, guys. So yeah, just go through this one, and if you face any issue, just let me know. And what about your blog, guys? Jaya and Ravi Teja. Ravi Teja, you said last session like you will share after the class. May I know the reason why it's taking longer time?
Sir, it's there in different laptops, so I'm checking. I will send it, sir, by the end of the day.
Not end of the day. Send in the next 1 hour.
Okay, sir.
Jaya.
Yes, sir. I'll share it, sir.
Okay.
Yeah.
Said because it's already like approx 1 week, right?
Yes,
So
sir.
said it so that I can check it out once.
Yes, sir.
Okay. Fine. And any other application that like assignment that I mentioned in a group? Anything apart from the blog?
You have given one
Uh,
in the last class.
yes, sir.
Besides that, there's nothing else, sir.
Okay, fine. So try to explore parallelly. Okay. And if you guys face any issue, try to complete the assignment, guys.
Yes.
Okay. So when you work on the assignments or the project, then you will get the idea. Okay. So then you will get the idea. Okay. So how that we can think whenever we are deploying, like generative AI application is not easy to build for the production purpose. Okay, so like I can say in like last 2.7, yeah, 2.7, 2.8 years. Okay, so till now I just deployed only two applications in a production. Okay, so it's too complex. Okay, so whenever you start writing the code, then you can explore whatever the features that you are going to add, whatever the things that you need to add, whatever the process that you need to follow to do the processing, because sequence to sequence data is not easy to handle it. Sequence to sequence, it means that we are talking about the textual data. Okay, and in a real time, let's say if you're using the chat GPT or a Gemini API, okay, or let's say for the audio data that we have used a DeepGram API or the assembly AI. Okay, so API that we are using, but how that we can fine tune those things, how that we can develop the application, we can't rely on the third party API. So if you develop the application, no one going to allow you, like if I talk about the big MNCs, okay, so in a big MNC that you can use the API is totally fine. But let's say if you are working in a startup, then no one going to allow you to use the third party API. Okay, because everyone say, okay, so build the model from the scratch or just fine tune. We can't rely on the other API. Let's say later part, if they close, in this case, the entire system, it will get collapsed, right? So that's why most of the startups, they say build the model from the scratch. So whenever you add the new features, whenever you build the model from the scratch, then you will get the idea, okay, so these are the things that we are doing in a like wrong way. These are the processing that we need to do. These are the steps that we need to follow. Okay, so that's why whatever the assignment that I mentioned in the group, follow it and try to complete it, all the assignments. Okay, if you face the issue, I'm here. You can just ping the message in the group, or you can just ping the message in my personal team. Depends upon the query that we can connect and we can discuss. Okay, fine guys.
Okay.
Yes,
Okay.
sir.
Fine guys, so yeah, this is all about the today's session. Just go through it, okay, and next that we can connect on the Wednesday, okay, and then we have the Saturday, okay. So complete it, because next research paper, it will take a longer time, minimum 2 weeks, as I mentioned, 4 to 5 days. Okay, 4 to 5 days, like I can say 6 to 8 hours. Okay, so going forward after Diwali, I will try to like stretch the timing. Okay, so 1 hour 30 minutes, 40 minutes, okay, and then we can finish it like within a 4 to 5 class, not more than that. Okay.
So we have next class on Wednesday or Thursday?
No, ma'am. Wednesday. Thursday we
I
have the
have some
like
work.
Deepavali, no? Thursday we have Deepavali, ma'am.
Wednesday 30th, right, sir?
Yes, so it's 30th that we have the Diwali, right?
Okay.
Ravi Teja Jaya.
31st,
Yeah,
right, sir?
31st we have the like Deepavali, no? So Wednesday we can continue the session, ma'am, and then like next session that we can continue on Saturday or Sunday.
Sir, same time I have some work. So in Indian
Okay,
time, 4 o'clock. So 1 hour
okay,
ahead.
so yeah,
Can
guys,
we
you guys can
postpone the
just
time?
confirm. So if possible, we can change the timing. No issue. I don't have any.
Yeah,
Okay,
time.
so when we have the Dhanteras, is it tomorrow or day after tomorrow? I need to check. Okay, so like during Dhanteras, I'm not available, guys. Okay, so let me check, and then I will ping the timing and the day in the group.
Okay, sir.
Okay, Ravi Teja Jaya.
Okay.
Let me
Yes,
Okay.
check
sir.
for the Dhanteras. Okay,
But
fine, guys. So yeah, let's
sir, can
conclude
you
here.
make sure you don't keep it before 4, because if college has
By
been
EOD, I will
extended
update you.
lately. Yeah.
By EOD, I will
After
update
4,
you. Don't worry.
anything's fine, sir.
After 4, no?
Yes, sir.
Okay, then most probably like we can continue on Friday or Saturday, or let me check. Okay, if possible, we can continue tomorrow.
Because if class is still 2:34, depending on what goes on in the college, so I can't really rush
Tomorrow
back
we
if
can
it's
continue,
before
right?
4. Yes, sir. Tomorrow is fine.
Yes, ma'am. Can you please
Yeah,
confirm?
yeah. Okay, sir. Tomorrow is okay, sir.
Okay, let's continue tomorrow then. Okay,
Okay,
next
sir.
after that we can continue on Saturday.
Sure,
Yes,
sir.
sir.
Okay, as we have the Diwali, so we can continue on tomorrow and then Saturday. Okay.
Okay, sir.
Yes, sir.
Okay, guys. Okay, fine. Yeah. Thank you, guys. Yeah. Bye.
Thank you, sir.
Thank you.
Yeah.